I have another riddle for you.
Why would we do another riddle?
If you do it, I'll show you who I am.
Step back, Natalie. I got this. Use the ratio test to find R. When doing the ratio test up here, we can ignore the negative. The negative disappears because it's absolute value. It doesn't matter if you leave it in or out, because eventually it will disappear. So let's just set up the ratio test. Where in absolute value, it's 3 to the n plus 1 minus 1 times x to the n plus 1 over n plus 1 times n over x to the n times 3 to the n plus 1. From our setup, we can begin to simplify. In a limit, n over n plus 1 goes to 1 due to L'Hopital's. 3 to the n over 3 to the n minus 1 goes to 1/3 to the negative 1, which is just 3. And using our power rules, x to the n plus 1 over x to n leaves us with just x. Therefore, the limit is 3 times x in absolute value.
How do we find the radius of convergence, though?
Well, for the power series to converge, the result of the limit has to be less than 1. Solving for the absolute value of x, we get 1/3, which is our r or radius of convergence. The first four non-zero terms of the Maclaurin series for f prime, the derivative of f, express f prime as a rational function for absolute value x less than r. So, there are two parts to this question. When solving riddles by your boss's arch nemesis, make sure to always read the full riddle. There are two ways to do the first part. One, we know f of x, so to find f prime of x, we just take the derivative of the series, where the n's cancel, leaving us with negative 3 to the n minus 1 power times x to the n minus 1 power.
Something feels off. Shouldn't you take the derivative of the other terms?
No, since it's d dx, you're taking the derivative with respect to x. But there's something else we need to address before we write out the terms. The pitfall of this method is that when taking the derivative, you often will have to compensate by moving up one term, but not always. When we check it, the first term should always be the derivative of x. So, in f prime of x, when n equals 1, it is equal to 1, while in f of x, n equals 1 of x is x. So in this case, we don't skip a term.
So in this case, if I forgot about checking the first term, that would be okay, right?
In this specific case, yes, but that doesn't mean you shouldn't check it. Let's write out the terms. N equals 1 is 1 times x to the 0 plus minus 3 x to the first plus 9 x to the second plus negative 27 x to the third, which is just 1 minus 3x plus 9x squared minus 27x cubed. To show strong writing at the end, the plus ... is true because the equal sign f prime of x is equal to an infinite series where you keep on going on with terms. The nice thing about this method is that it's easy to find the power series and convert it back to a rational function. Since most power series are written in n equals 0, if we make n equals 0, we get negative 3x to the power of n, which is convenient because it follows the rational pattern of x to the n. So in this case, the rational function is 1 over 1 plus 3x.
I think it's just easier to take the derivatives of the terms listed out. On the top right, you can see they've listed the first three terms, so we need to find the fourth term using a power series. F of x, where n equals 1 is equal to x, n equals 2 is equal to negative 3 halves x squared, n equals 3 is 3x cubed, and n equals 4 is negative 27x to the fourth. Then we just take the derivative, which is equal to 1 minus 3x plus 9x squared minus 27x cubed plus ... From here, we need to recognize the pattern of multiplying by negative 3 each time, as well as x, which satisfies the power series, n equals 0, to infinity negative 3x to the power of n, which again is 1 over 1 plus 3x.
Not too shabby. Write the first four non-zero terms of the Maclaurin series for e to the x. Use the Maclaurin series for e to the x to write the third-degree Taylor polynomial for g of x equals e to the x f of x about x equals 0. This riddle is another two-parter. First, let's find the expansion of e to the x. The power series is the series n equals 0 to infinity x to the n over n factorial, which is one of the most basic ones you should memorize before the test, or the riddle. The first 4 terms is then 1 plus x squared over 2 factorial, or just 2, plus x cubed over 3 factorial, or just 6. If g of x is e to the x times f of x, then what you should do is write out the terms of both and then begin multiplying to get the same powers of x. Sometimes it's hard to know how many terms we should write out for the power series, and then multiply them together to get the correct Taylor series. Of course, it's hard to tell how many terms we might actually need to multiply the Maclaurin series out. But here, Mr. Grunutson is giving us a hint in his riddle. He says, write the first 4 non-zero terms of the Maclaurin series for e to the x. That's a hint that's probably all we need from e to the x. And at the top, we already have the terms of the series listed out. So that means that's also probably all we need from the series. But it's always better to have more terms listed out than fewer, because that means you'll have some extra terms that you can just cut off. It's impossible to get x to the 0 or a constant here, so let's begin with x to the first, which here is only made up by 1 times x. X to the second power can be made by multiplying x times x and negative 3/2 x squared times 1. Since it's impossible to get any more, we move on to x cubed. Which can be made by x squared over 2 times x times negative 3/2 x squared, and 3x cubed times 1. The question asks for a third degree Taylor polynomial, so this is as far as we need to go. Thus, T3x is x minus x squared minus 3/2 x squared, or x squared plus 1/2 x cubed minus 3/2 x cubed plus 3x cubed, or 2x cubed. What's important here is to keep track of what you're multiplying to make sure you don't miss anything or multiply the same things twice. For more help, try the 2011 BC FRQ number 6 on Form B or the 2009 BC FRQ number 6. If you need another refresher on multiplying power series, go to 10.2 Properties of Power Series on LibreText and scroll down to exercise 10.2.4 for a good problem to try.
We finished both riddles. Now tell us who you are.
Here I am!
Why would we do another riddle? Where's the camera?
I forgot to put my beautiful ring today.